Welcome to Easy Engineering. Today we're going to talk about compressed air storage and its implications, especially in utilizing compressed air for blow-off or cooling applications. So, how is compressed air stored? It's stored under pressure. Normally how it works is you get a, say, 120-gallon tank, and the pressure is set so that the compressor fills that tank, and it sort of turns on when the pressure falls below a certain level, say 80 pounds pressure, and then it continues to fill that tank up until it hits a higher pressure, say 120 pounds, and then the compressor turns off. So what happens is you've got compressed air in this tank under pressure, somewhere between 120 maximum and 80 pounds minimum. At 80 pounds, the compressor turns on again, starts filling up the tank. But as long as that pressure or that air is drawn off from the tank between 80 and 120 pounds pressure to what it's set at, the compressor is not going to operate. You're going to be operating off storage. Okay? So how much air is really in that tank? You can use a calculation using a very simple engineering formula. Pressure 1 times volume 1 equals pressure 2, volume 2. That's a very standard engineering formula. So let's say you have 80 pounds pressure in that tank. The absolute pressure is the 80 pounds that's in the tank plus your atmospheric pressure of 14.7. That gives you absolute pressure. So 80 plus 14.7 times the volume of the tank. 120 gallons is about 16 cubic feet. Okay, so that's P1, V1 equals P2, that's the 14.7 pounds pressure in the atmosphere, that's standard condition, times V2. The V2 works up to 103.1 cubic feet. That is that compressed air that's in the tank. If it was expanded at 14.7 pounds pressure, that would occupy 103.1 cubic feet at the standard condition of 14.7 pounds per square inch. Okay? Do the same calculation at 120 pounds pressure. 120 plus 14.7 times a 16 equals V2, or P2 rather, which is 14.7, times your volume that it would occupy at standard condition. Turns out to be 146.6 cubic feet. So at 120 pounds pressure, if you take that compressed air in the tank, put it to standard conditions of 14.7 pounds per square inch, it would occupy 146.6 cubic feet. So the difference is 146.6 minus 103.1 equals 43.6 cubic feet. That means you can draw from 120 pounds and let the pressure go down that tank down to 80 pounds, draw off 43.6 cubic feet of air at standard condition before the compressor even turns on. All right? Now, let's take, for example, a 12-inch air knife. This is a compressed air operated air knife. What it does is it takes compressed air and it draws in air from the atmosphere, converting some of the pressure coming out of the air knife into flow, amplifying airflow. This way you reduce overall energy consumption using compressed air. But it still consumes air. A 12-inch air knife at about 80 pounds pressure of use, it's 80 pounds pressure going in there, coming from that tank through a regulator to keep it at 80 pounds going in the air knife, is going to consume about 35 standard cubic feet per minute air. That's cubic feet per minute at standard conditions. So take that 35 cubic feet per minute, divide it into the 43.6 cubic feet, you get 1¼ minutes. What that means is you can operate from that tank that we took as an example, operate that air knife from storage only, the compressor doesn't even have to be on, for 1¼ minutes. Now, intuitively, recognize the implications of that. If you have an intermittent application for compressed air blow-off, you're not going to be using the energy all the time. When the air knife is off and it's not operating and the pressure falls below 80, that compressor will turn on and recharge that tank in the intermittent time that the unit is not being consumed, or the air is not being consumed. So if you have an intermittent application, your overall energy consumption is going to be a lot less than if it's used continuously. Secondly, if we say at 80 psi it's using 35 CFM, at 40 pounds pressure, if you only need 40 pounds pressure to do the job, and many applications only need that kind of a low pressure to do the blow off, you're going to use only about 16 standard cubic feet per minute. That's going to double the time you can run off that storage. So your overall consumption goes down again. Your energy consumption goes down again. So when you're comparing the use of compressed air for blowing off versus a blower system for blowing off, recognize the effect on energy reduction in using a compressed air system for intermittent use and also the actual pressure that you need to use. So next time, another topic for easy engineering will be another topic concerning compressed air.